This video explores the sum of the inside angles of polygons, the interior angles of polygons. And we've already examined triangles. We know that if we add all the angles inside of a triangle, so I have a diagram of a triangle here, if I were to add those three angles together, I know that the sum, the answer we get when we add, is 180 degrees. We're going to complete the following chart by putting in the polygon's name. We have our diagram. I've given you all the diagrams. We're going to count how many sides it has and how many triangles we can divide that polygon into. So a triangle has 3 sides and there is only one triangle, so the sum of the interior angles is 180 degrees. Now we also have explored quadrilaterals, and we found that if we were to add all 3 angles together all 4 angles together in a quadrilateral, we found that the sum of that would equal 360 degrees. So a quadrilateral has 3 sides, and I wrote the number 4, and I'm not sure why that happened, because I'm not sure why I said the number 3. Let's try that again. A quadrilateral has 4 sides, and in terms of how many triangles you can break this up into, I'm going to show you what we're going to do here. We're going to pick a vertex on our polygon, and what we do is we just join that vertex to other vertices. If I join that vertex with the first vertex, it just creates a side that already existed. So that line, that little red line that I've drawn here, divides that into 2 triangles, one on the left side here and one on the right side here. And if I look at my triangles, I could say that this was 180 degrees. If I add these 3 angles together, that equals up to 180 degrees. And if I add these 3 angles in this triangle together, it equals 180 degrees. So we have 2 triangles here. Another way we can talk about the sum of the angles in a quadrilateral would be that there's 2 groups of 180 degrees, 2 triangles in there. That is equal to 360 degrees, which is what we found yesterday when we actually tore off those corners of our quadrilateral and lined them up together. We found that they added together to be 360 degrees, a full revolution. All right, my next diagram, if we count the sides, we have 1, 2, 3, 4, 5 sides. And again, I'm going to pick a vertex. I'll take the top one here, and I'm going to join it to the other vertices of my triangle, or of my 5-sided shape. And what happened here is I now have 1, 2, 3 triangles that came out of that. So I would have a group of 180 degrees in this triangle. My second triangle, the middle one, has another group of 180 degrees. And my third triangle has a third group of 180 degrees. So altogether, this plus these 3 parts together, plus this, plus these 2 parts, that would be 3 groups of 180 degrees, 3 triangles of 180 degrees. And if you do 3 times 180, you get 540. So that equals 540 degrees. Now, if you don't know what the name of a 5-sided figure is, you could Google that. You could look it up using your technology. But a 5-sided figure, any volunteers? Bueller? Anyone? Okay, a 5-sided figure, I didn't hear anything on my end, you might be saying it out loud in the classroom, is called a pentagon. Pentagon. Okay, 5-sided figure. And I've drawn irregular shapes. I didn't make all the sides equal in length. I just drew them, made sure I had enough sides. All right, so your job now is to finish this up. You're going to figure out how many sides are in my next diagram. You're going to pick a vertex, draw your triangles from that vertex, figure out how many triangles there are, and then use that to figure out what the sum of the interior angles would be, and also look up the name for that sided figure. Okay, finish up the diagram or the chart here. You can wait to the next video or the next part of the video, put this on pause, and then we'll take it up. Okay, put the video on pause if you have not done so. Try to finish the next, and then we'll take it up. Okay.
Okay, so if you look this one up, it has 6 sides to it. 6-sided figure should be called a hexagon. If I pick a corner, so I'll pick the top one, and I join it up to my other vertices. Altogether I have 1, 2, 3, 4 triangles now. So I'm going to have 4 groups of 180 degrees. And 4 times 180 is 720 degrees. You can check that on your calculator. It should equal 720. Okay, my next one had 1, 2, 3, 4, 5, 6, 7 sides to it. If I pick a vertex and join my other vertices to it, I seem to be missing, there we go, my other vertices, altogether I have 1, 2, 3, 4, 5 triangles. So I'm going to have 5 groups of 180 degrees. And 5 times 180 is equal to 900. So the sum of those inside angles for this polygon with 3, 4, 5, 6, 7 vertices or 7 sides, the sum of the inside angles would add up to 900 degrees. Now, my question to you is, did you look up what a 7-sided figure is called? Hopefully you have. If you haven't, you should have gotten a heptagon. Now, some of you might have also gotten a septagon. These are both used to describe or to talk about septagon, a 7-sided figure. Okay? Depends on which language we're deriving from, whether we're deriving from Latin or whether we're deriving from, I believe it's Greek. All right, next one. You should have had that there were 8 sides to it. If you pick a corner, you're going to have 6 triangles. 1, 2, 3, 4, 5, 6. 6 triangles. So you're going to have 6 groups of 180 degrees, which is equal to, that's right, 1,080 degrees. And that's called, 8 sides is called an octagon. The squared circle. All right, so in general, and I shaded this out because, like, I don't know how many sides I'm going to work with. I'm going to say there's n sides. Okay? In general, we call these polygons. And if there's n sides, if you look in your chart, there is a relationship between the two numbers we have. If you look at the number of sides and compare it to how many triangles you have, when we had 8 sides, there were 6 triangles. 7 sides had 5 triangles. On my previous slide, I had 6 sides having 4 triangles. So there is a relationship here. If I have n sides, I'm going to take this number that I have, and if I were to take 2 away from it, it gives me the number of triangles. So if I have n, if I want to take 2 away, I'd be subtracting 2. And then, when we want to come up with our generic formula, it's the number of triangles, so this n minus 2, these numbers match, so I'm going to have n minus 2, it has to multiply the 180 degrees. Okay, and that's how we're going to get the number of sides in any polygon. All right, so I'm going to go to a new video, just because YouTube likes me to keep my videos short. I'm going to do a new video for the next part.